Okay, this is our fourth video in the limits series, and this is the last one, and we're talking at limits at infinity. When I talk about that, I want you to keep in mind, as you're talking about mainly rational functions, or fractions if you will, and when I talk about at infinity, there's going to be two types. One is, if we're talking about horizontal asymptotes, then your x is going to be approaching positive or negative infinity. Okay? So we're going to be talking what's happening, what's my end behavior. Remember, we've talked about that. With vertical asymptotes, your actual limits are going to be at positive or negative infinity. Okay? So let's start with this. If f of x gets as close to a number L as we please when x gets sufficiently large, then we write the limit as x approaches infinity of our function is the limit. Now we can make similar statements when x approaches negative infinity. Recall the rules of horizontal asymptotes when looking at rational functions approaching positive or negative infinity. So let's go through this. These are the three that I had you memorize before. So here I have a rational function, p of x over q of x. So the first one is if the power, so I'm going to talk about this one, if the power of p of x, the highest power, I should say the highest power of p of x equals the highest power of q of x, then you're going to find the horizontal asymptote by just using the coefficients in front. For example, if I had 3x squared over 2x squared, it's approaching 3/2. It's squared here. Okay? The next one is if the power of the numerator, so if the power of p of x, which is the numerator, is greater than the power of the denominator, power of q of x, okay, then there is no horizontal asymptote. If the power of p of x, when I say the power, the highest power, is less than the power, the highest power of q of x, then y equals 0 is your horizontal asymptote. So those are the three rules. Okay? Let's look at the definition here. A line y equals b is the horizontal asymptote of the graph of the function y equals f of x if either when x goes to positive infinity of this function, it's b, or if x goes to negative infinity of this function, it's also b. So that's considered a horizontal asymptote. And remember, we kind of talked about that. We use the word end behavior when we talked about rational functions. What's happening at the end behavior? Recall how to find the vertical asymptotes of a rational function when approaching a limit from either the left or right. And remember, vertical asymptotes are when your denominator, so here I have the same function I had above, f of x equals p of x over q of x. Remember how we took q of x and we set it equal to 0. That gives rise to your vertical asymptotes. So when you have vertical asymptotes, though, you have to approach it from both sides because you're looking from the right, it could be positive or negative infinity, or approaching it from the left of the same number. You're looking at your actual limit being infinity. So that's a little bit different. Now let's practice a couple of these, and I picked a graph here, and this is the graph of y 1 over x. Okay, so we'll look at it. Now there's a lot of ways you can look at this, so we're going to look at it a couple different ways. First of all, let's look at the limit as x approaches infinity of 1 over x. Let's look at the limit as x approaches negative infinity of 1 over x. All right, so we're going to look at basically the end behavior of this graph. All right, so if I were looking at this here, As I go to infinity, positive infinity, it looks like my y values are approaching 0. Over here, if I go to negative infinity and I look at my graph and I follow it through, it looks like I'm approaching 0 also. So it looks like the horizontal asymptote is y equals 0. Well, let's look at it. If I have 1 over x, so here's my function is 1 over x. You could really write this as 1x to the 0 over x to the first power. See how the power on the top is smaller than the power on the bottom? So this is the one we just learned. That means y equals 0 is going to be my horizontal asymptote. So that's basically my end behavior as I approach positive or negative infinity. Okay? That's how that one works. Now, here's another way. This one also has a vertical asymptote. Looks like right here in the middle. So you could write it this way. The limit as x approaches 0 from the right of this function, and the limit as x approaches 0 from the left of this function, and see what happens. So let's do from the right. So if I approach 0, so I'm coming towards this way. I'm not going to the right, I'm going to the left here. So as I approach this way, it looks like my function is going to positive infinity. If I were to approach 0 from the left, as I approach 0, it looks like my y's are going down to negative infinity. So see how your answer is infinity or negative infinity if you approach a vertical asymptote. See how you're going and approaching infinity for your x's here and negative infinity here. You're approaching a number or a value. That's your horizontal asymptote. That's the difference. Okay? Let's look at this graph. This is 5x squared plus 8x minus 3 over 3x squared plus 2. So let's look at the limit of this function. And I'm just going to call this f of x, this function f of x, because it's big. So I'm going to say the limit as x approaches infinity of this function f of x is what? And the limit as x approaches negative infinity of this function is what? All right? So let's look at this one. I'm going to approach here. Here's positive infinity right here. Negative infinity over here, right? So as I approach positive infinity, it looks like my function is approaching 5/3. And it looks like as I approach negative infinity, it looks like eventually it's going to approach 5/3 there. So it looks like a horizontal asymptote. Well, if you look at this, isn't the power on the top the same as the power on the bottom? So if I circle those highest powers, see how my horizontal asymptote, or HA, is y equals 5/3, and that's how it shows on the graph. So a lot of times when you approach negative and positive infinity, you're talking about the horizontal asymptote. All right, let's look at this function right here. And I have 11x plus 2 over 2x cubed minus 1. So let's look at it and talk about the horizontal asymptote just to see. So here's my highest power on the top and highest power on the bottom. If you'll notice, the highest power on the top is smaller. So if I were doing the horizontal asymptote thing, I would say, oh, y equals 0 is my horizontal asymptote. Now let's see if that helps us with our limits. So I'm going to do the limit as x approaches infinity of our function f of x, and limit as x approaches negative infinity of f of x, and see if it looks like it's approaching 0 on both sides, and it is. So that's where that comes from. Okay? Now, I'm going to be giving you these functions, and you're going to have to come up with what you think the limit is as you do this. So the horizontal asymptote approach is perfectly fine if you're approaching infinity and negative infinity, as long as you show me your work. Okay, so I have this function, y equals x plus 3 over x plus 2. Okay, so we're going to look at this right here. So I'm going to look at the limit as x approaches infinity of this function, x plus 3 over x plus 2. We're going to do the limit as x approaches negative infinity of x plus 3 over x plus 2. And then we're also going to approach negative 2. I'm going to do the limit as x approaches negative 2 from the left of this function. And I'm going to do the limit as x approaches negative 2 from the right of this function. So we're going to find quite a few things. So recall that if I do, as I'm approaching infinity, I'm looking at the horizontal asymptote. If I'm looking at from left to right, this is usually our vertical asymptote. So, all right. So let's look at the horizontal asymptote. So if I were going to do the work on this, let me erase this circle here. I would take the highest power of the top and bottom and cancel out. It looks like it's the horizontal asymptote here is going to be y equals 1. Is that what the limit is as I'm going to positive infinity? Well, yeah, that's approaching 1. As I go to negative infinity, yeah, I'm approaching 1. So that is the horizontal asymptote, okay? Next, I'm going to approach negative 2 from the left and right. So that's usually your vertical asymptote. So if I approach from the right, it looks like I'm going to positive infinity. And as I approach negative 2 from the left, it looks like negative infinity. That is our vertical asymptote. And how did we get the vertical asymptote? Well, the vertical asymptote is, remember, we took the denominator, put it equal to 0, and that's x equals negative 2. So that's when I approach that asymptote, then usually your limits are to positive or negative infinity. All right, this next and last page of your notes, basically, is some practice on how you're going to do these. So I'm going to go through this with you. And some of these we've already done before, but you're not always going to have the picture. So here I have a rational function. I'm approaching infinity. Now you cannot substitute infinity in there. You can't. But if it's a rational function, and if you're approaching positive and negative infinity, I can think of horizontal asymptote. So I'm going to say, oh, let me do the horizontal asymptote. So if I do, the highest power of the top and bottom is a negative 3x over 5x. So if I cancel out the x's, I have y equals negative 3/5 is my horizontal asymptote. So the limit as x approaches infinity of this function, 4 minus 3x all over 5x plus 7, is going to be negative 3/5. And you can graph it and check it. Let's look at this one. Again, this is a rational function, so we're going to look at horizontal asymptote. Look at the highest and highest power of each. And I see the power on the bottom is larger than the power on the top. So this, if I know my horizontal asymptote rules, the limit of that should equal 0. So we can use horizontal asymptote rules here. The limit of this one, horizontal asymptote rules on this one, highest power of the top and the bottom. The power on the top, and this should be a squared, sorry, let's change that to a squared. They're the same, so if I cancel those out, that's a typo on my part, 5/3. Now, let's look at some of these other ones as we go to infinity, and sometimes you just got to graph them and look at it. But if you look at infinity, so if I were to try to plug infinity in here, I'm going to say use the word huge, okay? If I have 1 divided by huge, so if I get bigger and bigger and bigger numbers, the higher and the more you divide something by bigger and bigger numbers, the more you approach 0. So basically, you're saying here, this is the same as saying the limit of x approaches infinity is I've got the sign of 1 over huge. I'm going to put the word huge in here so they can see this, 1 over huge. Let me erase that, make that a little bit nicer. The sign of 1 over huge. This essentially goes to 0. And if I asked you what the sign of 0 is, you'd say, oh, that's 0, and remember you're in radians. So the limit as I go to infinity of 1 over x is 0. So you can look at it that way. The other thing you can look at it too is if you had x to the 0 over x to the first, if you did a horizontal asymptote, it looks like it's going to approach 0. It does, okay? Now, here I've done the left and right of 1 over x, which we saw in the picture before. And if you look at the example we covered before, as I approach from the right, of 1 over this. So I know it's going to be vertical asymptotes because I'm approaching right and left. And we had done this before. This is positive infinity and negative infinity. You can look back and double check that to see what the graph looks like. But you should always sketch the graph to see, especially with vertical asymptotes. Here I have a plus and minus. Here's another vertical asymptote. So if I have a plus and minus and I want to put those in there, I'd look at it. You'd have to graph it. And the graph kind of looks like this. This one we didn't do previously. So here I have a vertical asymptote as 1 if you were to put your denominator equal to 0. And your graph will kind of look like this. This is a very poor sketch, but you'll get the idea. And this one kind of looks like this. So as I go to 1 from the right, it looks like it's going to positive infinity. As I go from 1 to the left, it looks like it's going to negative infinity. So those are some practice with infinity. We're going to practice more in class, but that concludes this video.